Hello, welcome back to Fundamentals of Physical Geography and the first of two short sessions on time as a historical and geological framework for physical geography. People often talk about space, place and environment as being the key themes of geography or physical geography. You can add time to that as a fourth big theme. So what we're going to do in these two sessions is first of all look at time as a context or a framework within which physical geography happens, and secondly look at how different physical geographers have thought of time or used time in that way when looking at how landscapes change or evolve or develop over the course of time. Before we get into the session in detail, there's an activity I'd like you to try before we get started. Most of the students on this module arrived on the planet about 20 years ago. About 2,000 years ago, there were Romans here where we're based at Kiel doing this module. There were Roman settlements in this area 2,000 years ago or thereabouts. About 20,000 years ago, there were glaciers here covering this area. The Earth is about, well, there's the long number for you there, 4,500 million years old. So put yourself and put your history and put your glacial history into context and try to draw a scale diagram of some kind that shows that timeline. You're not going to be able to fit it on one sheet of paper probably if you try drawing a straight line. So how big would your bit of paper have to be if you gave, say, a centimetre for the last 20,000, a centimetre for the last 2,000 years, say? Or can you do it on a spiral or do it in some other way? Just try some way to represent yourself in the context of that scale of the history of the planet. There are lots of examples on the internet that you can find that will show you different ways of doing this, but try and represent that in diagrammatic form and try and think of some analogy to illustrate the age of the Earth relative to your own. Maybe pause the video for a minute and just do that before coming back and carrying on with the rest of the session. As always, there's set readings for these sessions. The main bit of reading I'd like you to do this one is from the Matthews and Herbert basic book, The Very Short Introduction to Geography, pages 35 to 43. And I'll put some more suggestions and advice for reading and web links and so on in your resource pack on the KLE. Okay, so you started off by trying to draw a diagram or think of an analogy to put yourself in context with the age of the planet. Let's begin by looking at how physical geographers and geologists get their heads around that enormous amount of time and the difference between our day-to-day timescales and the timescales over which things are happening at a planetary, from a planetary perspective. Now, geologists typically divide Earth's history into 4 eons. The Phanerozoic, the Proterozoic, the Archean and the Hadean. The Phanerozoic is the period when there's abundant life. The Proterozoic, there are only basic life forms. And those are separated from the previous eons when there basically wasn't any life on Earth. And you can see on the right hand side each eon is broken down into eras. So the Phanerozoic there have expanded, and you can see it's broken down into eras of the Cainozoic, the last 65 million years, the Mesozoic, the Paleozoic, and so on. The Cainozoic, Mesozoic and Paleozoic are recent, middle and ancient life. That's what the words refer to, and Precambrian is a general term that applies to all the pre-life or early and pre-life eras before that. At this stage, I should just point out some of the terminology or usage on this page. We're using symbols here. MA stands for millions of years, M for millions, A for annum for year, so 65 million years, etc. The GA, that's giga years. So a giga year, GA, is 10 to the power 9, or thousands of millions of years. So 2.5 gigayears is 2.5 thousand million years. 4.5 thousand million years back to the approximate date of creation of the Earth. You might also see these written with a Y instead of the A to represent the year. So GY is gigayears, MY would be millions of years. Also watch out for K, meaning thousands, etc. So make sure you're familiar with that kind of terminology and usage when we're using numbers throughout the course. So these slides, we're going to gradually zoom in from the eons down to the eras, and we're going to focus in increasingly on the more recent time periods that become more and more relevant to what we're looking at in physical geography as we move closer to the present. So on this side, we're zooming in and looking a bit more closely at the Cainozoic, Mesozoic and Paleozoic eras, and we're seeing that set of eras is broken down into a set of shorter periods, and this is a geological timescale that a lot of you will already be familiar with: Cambrian, Ordovician, Silurian, Devonian, etc., up to the Quaternary, reaching towards the present day at the top of the diagram there. So if you're the kind of student that likes memorizing lists or systems, well, this is one for you. And the geologists amongst you will presumably already know this, but you certainly need to be aware of the Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic, Jurassic, Cretaceous, Paleogene, Neogene, Quaternary. A key point to think about here is that our detail of physical geography knowledge decreases with distance into the past because we lack so much evidence as we do for more recent periods. So we have an idea of the big picture from early Earth history, but we have increasing detail as we get closer. Another key point is that a lot of the physical geography of the planet today is a legacy of recent geological history, not so much of ancient geological history. So for a lot of physical geography, we tend to focus on the upper end of this geological timescale, the Cainozoic. In particular, we tend to focus right at the very top of that column in the Quaternary, which is the last 2.6 million years, and the Quaternary is broken down into the Holocene, which is the last 11,500 years or thereabouts, and the Pleistocene, which is the remainder of that Quaternary. So looking back over those last few slides, you need to know the basic geological framework, including the 4 eons, the eras, the Phanerozoic, the main headings within the geological records from the Cambrian to the Quaternary. You need to know about the Quaternary itself and its key subdivisions, the Pleistocene and the Holocene. You need basically to memorize that and to know that. That has to be almost second nature to you. And you need to be able to put dates on those. So if I say that something is of Carboniferous age or Cretaceous age, you'd have an idea of when I was talking about. If you're not already familiar with that from your previous study, then now is the time to go away and do some independent research and just familiarize yourself with that geological column. Because that's the historical framework within which physical geographers think. And if we look back over that history of the planet, here are some key events in Earth history that are essential background to some of the things that we'll be covering later in the course. First of all, we can recognize events or stories, histories related to continental drift, as we used to call it, caused by the process of plate tectonics that we're going to talk about a lot more later on in the module. So here in the Triassic, and we're looking here about 210 million years ago, all of the continents that you would recognize from today, North America, South America, Africa, and so on, those are merged together into this supercontinent of Pangaea. But over the course of time, these moved around, and here's what the map of the world looked like later than that, about 65 million years ago in the late Cretaceous. And I'd just like you to draw your attention to one particular characteristic here, which is this gap which has opened up. If I flick backwards to the previous slide, North America, South America, and all the continents joined together so that there's very little communication between the ocean on this side and the ocean on that side. But then as we move forward to the late Cretaceous, there's now this routeway, if you like, so that you can have a circumglobal circulation of ocean water because of this gap which has opened up between North and South America, as well as the gap between South America and Africa. But this gap between North and South America had opened up by about 65 million years ago. But then, starting about 15 million years ago and culminating by about 3 million years ago, that gap closes again and North and South America join along the Isthmus of Panama. So the country of Panama that we're familiar with now is in there, and that area is called the Isthmus of Panama. An isthmus being a narrow gap between two landmasses where they're not quite separated, but they're just joined by a neck of land. So that Panama Isthmus fills in what used to be the Panama Gap, and that's had a major impact on the potential for globally circulating ocean currents. And changes such as that to ocean currents have a major impact on climate as well. Now, everything in physical geography always turns out to be connected, and that first example I've been talking about, continental drift or plate tectonics, the movement of the continents around the planet's surface, that's closely related to the second example I want to talk about, which is environmental change. It's no coincidence that a major change in Earth's climate coincided with that story I was telling you there, the events of the closing of the Panama Gap. So thinking now about environmental change, climate change, which is going to be a big topic later on in this module, I want to think about the boundary at the bottom of the Quaternary period. So we talked about these different periods in geological history, and we separated out the Quaternary, which includes the Pleistocene and the Holocene. And we said this recent period is what physical geographers are really interested in. And on this timeline, we've got the present day here at the left-hand side, and this goes back 1, 2, 3, 4, 5 million years before present. And marked on here is an approximation of the global temperature, global climate. And here we're in a relatively warm period, and here as the graph drops down into lower temperature zones increasingly, we're moving towards cooler conditions today, but with a lot of oscillation, a lot of fluctuation, particularly in this period on the left-hand side of the diagram, whereas on the right-hand side of the diagram, things were generally warmer, and there was still some fluctuation in temperature, but it very rarely got, well, it didn't get below this line and start dipping into the cold conditions until we reach about here, 2.5 million years ago, which we're designating the start of the Quaternary because it is the start of this changed climatic regime with great variability, and variability that includes dips down into very cold conditions or ice ages or glacial periods. And notice that change in conditions from a warm period to a colder period with lots of ice ages, lots of glaciations within it, within the last 2.5 million years, that's happening just at the period where that Panama Gap is closing. And one theory is that the closure of the Panama Gap was one of a number of different factors that contributed towards the onset of our current glacial period, where we're fluctuating over the years between glacial and interglacial periods, right the way up to the present day at the left-hand side of the graph here. And I said earlier about the Quaternary being divided into the Pleistocene and the Holocene, the Pleistocene being the bulk of the 2.6 million years, then just the last 11,000 years or so being the Holocene, where you can just pick out on this diagram what's happening right at the extreme left-hand end. We've gone Ice Age, interglacial, Ice Age, interglacial, Ice Age, interglacial, blah, 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 all the way interglacial, Ice Age, and then about 12,000 years ago, we moved into the current interglacial period. After the end of the last little ice age. We might be dropping down into another ice age soon, or maybe human impact on the climate will mean that isn't going to happen. But for the moment, we're on this last little red warm spot on this diagram, and that's the Holocene. So just to give you some context on timescale, just to remind you before we move on to the next slide, here's today and here's 1 million years ago. So this period where there's been extreme fluctuation, lots of ice ages and interglacials, that's the last 1 million years. Let's move on to the next slide. And here we're just looking back about 500,000 years, just under 500,000 years. So we've expanded the very last section of that previous graph. And again, you can see here this fluctuation between ice ages, high ice volume, and interglacials, low ice volume, high ice volume, low ice volume. And that's mirrored on the graph at the top, low temperatures corresponding with the high ice volumes, warmer temperatures corresponding with the low ice volumes. And we have this opposing pattern running through the cycle: warmer temperatures, lower ice volumes, cooler temperatures, higher ice volumes in the last ice age. And then during the Holocene, this last change from high ice volume down to our current lower ice volume, coinciding with the change from lower temperatures to our current warmer temperatures. The Holocene is this bit right at the end, since the end of the last ice age, which was in here, and into this period of warmer, lower ice volume conditions. So that's really all I wanted to say at this stage about time as a context to physical geography. My main point is that it's important for you to understand to know about the geological column and the history of the planet, and to be able to put your finger on the ages of certain key events. And primarily it's important for you to realize that there are key events in the history of the planet that have had a major impact on our present day physical geography. And big themes such as the geography of the planet and, for example, environmental change, climate change, the coming and going of the ice ages. A lot of these things are strongly interconnected, and they relate to the long-term history of the planet. So it's important that you have the tools to talk about and to think about that long-term history. So take a little bit of time now to try to get your head around the time scales over which Earth's surface has developed. And then we'll move on in the second part of this session to talk about the way that physical geographers have looked at time in slightly shorter contexts when thinking about the evolution of landscapes